Now we're going to do force moves, and this may, in a degenerate sort of way, this is a greedy algorithm, but it's pretty boring. All right. So remember when the algorithm decided to reject a coin or reject an edge because it was forced to, then the fairy godmother is also forced, right? So that's the kind of forced moves that we're talking about here, right? So here's the example. The algorithm is forced to reject this edge, so she's forced to reject this edge, right? Right, so that's just kind of what I just said. All right, so let's, you've all taken 1090. Did any of you take it from me? Two of you. See, you're not independent. I told you you weren't independent, right? Oh, you took, oh, that's funny. That's funny. Fair enough. All right. All right. Anyway, if you've taken 1090 from me, you've seen the slide before, right? So we have various facts, right? Here's a fact: Miss Peacock loves Colonel Mustard, and we could have another fact: Colonel Mustard loves Miss Scarlet, and we could have another fact happened in the kitchen, and we could have another fact that Miss Peacock was murdered, right? And we can have various statements that we know, and we're going to consider two types of statements, one called a positive implication and one called the negative clause. And the one says that if all of these statements are positive, right, if all of those unnegated things are true, and, then that implies one unnegated variable, right? That's called a positive implication, right? And a negative clause is this or this or this or this happens, but we'll probably get into later. All right, let's say, remember what logical statement is, right? It doesn't mean causality, right? It doesn't mean that A happenings causes B to happen, right? It could be that not B happening causes not A to happen. It could be that some other thing causes them both to happen, right? All we are meaning by this is that there are no universes in which A is true. That is a typo, right? Everybody see the typo? It should be there's no universes which A is true and B is false, right? And this says, this one's right. This one says either A is false, or if A is true, then B has to be true, right? So this one's good. That needs another negation in there, all right? Hence, if A is false, what does this say? This is just trivially true, right? Or irrelevant. All right, so if all on the left are true, then the one on the right has to be true, right? If one on the left is false, then we don't care, right? Everybody buy that? Is this a positive implication? Well, do we have the and of a set of things over here? Yeah, it's the and of the empty set, right? It just happens to be empty set. So we're going to count this, right? And what does it say? What it says is that K is true, right? It's a statement that K is true. All right, here's a negative clause. It says one of these, it's the or of the negated variables. It says one of these has to be false, right? I just listed some. It's a new variable. We're going to have more variables. All right, so here are a bunch of more variables. All right, and so in general in life, if I give you a set of statements like this, and I want to find a setting of the variables that satisfies them all, is there a nice clean algorithm for that? No, right? It's as NP complete as they get, right? The only way to really do it is to try all settings of the variables, and if you have n variables, that's 2 to the n settings, right? So, but it turns out that if all your statements are these kinds that we've talked about, then it falls out. They're called Horn clauses. I don't know, probably after Mr. Horn. And we can easily solve the problem. All right, and I'm going to do a proof by example. Right, so it looks hard. We want to find a setting of all these variables that satisfies all these clauses, and we're going to just try to do the greedy thing and find if we can find a variable that needs to be forced. All right, so we're going to start with all the variables being false, right? And that's kind of like you're innocent until proven guilty, right? We're going to just assume everybody's false. And if everybody's false, what about these? Are those true? They're all true because the left-hand side is false, right? All right. Right. Then the statement's obviously true, right? And these guys, are these true? Yeah. Well, we said everybody to be false. Right? So these are obviously true too. Right? Because it says this is false, or this is false, or this is false. We started by setting all your variables to being false. Right? So that makes these true and it makes these true. There, we just solved the problem. Right? It was even easier than we had hoped for. Right? We found a setting that made them all true. Right? Everybody buy that? All right, that was fun, but we can get a little bit more exciting. All right, so now we add in here that x is true, right? And so that forces us to set x to be true, right? So we just say, hey, x is true. Now all of that forces all of these to be true, right? And in some ways, we can just, so that forces those to be true. And now see this guy here? That forces that one to be true, right? So we get all of those are true. And then this guy forces that one to be true, right? Which sets all those to be true. And that forces that one to be true, right? Which kind of eliminates that possibility. Right? And we have all those are true. And then we get down here that L2 is true. We actually get K's true too, right? We get K's true. And that eliminates those. And then K forces P to be true. And that eliminates that. And W we still have no reason to set it to be true. So it's still false, right? So that's happy. And down these guys, we still have these guys to be negative. So they're still true. So we have a solution, right? Does that make sense? So now that was great. We've satisfied them all. So let's just change our question slightly, right? It's the exact same. Before my question was this. I don't know. I changed it to this. Anyway, those guys, right? We forced K to be true, right? And we forced P to be true. So this can never be true, right? And that tells us that no one can ever satisfy these, right? Does that make sense? And that is it for horn clauses. And in fact, that is it for, we did this on Friday, right? So I think we're done greedy algorithms.